One of the most efficacious and promising modern pedagogical practices is mastery learning. Today, we'll look at the results from exploring effective implementation of mastery learning in a post-secondary environment. First of all, what is mastery learning? Mastery learning is simply mastering one lesson before moving on to the next. Some studies have shown that effective implementation of mastery learning can reliably provide an effect size of 0.8, a remarkable influence. Mastery learning can be achieved through one of two basic models. A group model, or Learning for Mastery, LFM for short, requires all students to proceed through the material at the same rate, not unlike most existing classroom environments. However, students are expected to perform at a high level of mastery. If they fail to perform at a B level or higher, for example, they must review the material until they have mastered it. This requires additional resources such as office hours, assessment retest, or peer support. In other words, as time goes by, progress continues at a steady rate, while effort may change drastically to meet the needs of the class. A second basic model is self-paced learning, or personalized system of instruction, or the Keller plan, PSI. This model allows students to go at their own pace through prepared material. The teacher serves as a guide when necessary, and students often meet with tutors regularly to move through the material. In this model, as time goes by, progress goes in fits and spurts, but effort can remain constant. Many research studies have explored mastery learning in detail. Meta-analyses have summarized and analyzed these data in order to find broader trends. These meta-analyses examine the variation of qualified mastery learning results. However, they found that the actual variation was much larger than the expected variation. Why could this be? This means that there are additional variables that strongly influence the overall effect of mastery learning. By using statistical models, including multiple variable analysis, researchers are able to identify other important variables. This leads to identifying common characteristics of effective mastery learning practices. The first was frequent formative assessments. The more testing for learning, the better the students did. Second, frequent timely feedback. The more feedback the students received, the better they did. Third, high mastery standards. The higher the standards for mastery in order to move on to the next topic, the better the students did. In fact, the most effective mastery learning required 100% performance on mastery targets. Finally, group-based approaches work best in a college setting. This is the group or LFM model, and it includes things like cooperative learning. In addition, the meta-analyses identified some important effects that correlated with mastery learning. First, students who experienced mastery learning showed increased instruction affect and content affect. This is one of the most exciting results from the study summaries, given the importance of these characteristics in education. Second, implementation of mastery learning closes the achievement gap. Hence, more of the students leave the class prepared for their next steps. Finally, one of the interests of this research was to identify discipline dependence of mastery learning practices. One could reasonably expect that mastery learning might have differing characteristics depending on the academic discipline. In fact, this seems to be consistent with the data, but not in an enormously impactful way. Why some fields show more sensitivity to mastery learning than others is still somewhat of a mystery. Hopefully, more research into the discipline dependence on mastery learning practices and effectiveness will answer this question. Thank you for joining me on this exploration, and I hope this information gives you insight into good use of mastery learning in the classroom.